Alright, so let's say you're given this diagram here of a guy skateboarding down a hill, and the question says, the skateboarder starts with 0 kinetic energy and 735 joules of potential energy. At the bottom, he has 450 joules of kinetic energy. Calculate the change in internal energy and the total change in the energy of the system. Note, there's a loss due to friction during this motion. To start, friction is a non-conservative force, which means we can't describe the change in energy due to the friction in terms of potential energy. However, it can be described in terms of the system's internal energy. We can see that throughout its motion, there's a force of friction that acts opposite to its motion. When the skateboarder skates down the path, the energy loss due to friction is transferred into heat. Both the tires of the skateboard and the hill become hotter. Note that the friction force does negative work on the block as it slides down, since we know the general equation work is equal to force vector times the displacement vector, which is also equal to ft cos theta, where theta is the angle between them. And so if we look at our diagram here, the displacement vector is going to be pointing in this direction here. The angle theta between them is going to be 180 degrees, and cos 180 is equal to -1. Therefore, we can conclude that the work due to friction is going to be negative. And during this motion, we can model the change in internal energy given by delta U int. And this change in internal energy is going to be positive since both the tires and the hill get hotter. This means that we can model the change in internal energy as the negative work due to friction, or more generally, the change in internal energy is equal to the negative work other, where work other is the work due to any other force that isn't conservative. So we can apply it to the conservation of energy equation, and we get this. This equation here is the most general model for the law of the conservation of energy. Note that the sum is always equal to 0, and this just comes from the fact that energy cannot be created or destroyed. It can only change in form. And so we can apply it to our example. This is our example here, and this is our law of conservation of energy equation. We can identify that K1 is equal to 0 since it starts at rest. U1 is going to be equal to 735 joules. This is the initial potential energy of the system. At its final position, K2 is equal to 450 joules. That's his final kinetic energy. And then U2 is going to be equal to 0 since U is equal to mgh. And at the final height, he's at the bottom, so height's going to be equal to 0. So these are the values given in the question, and we need to find delta U, delta K to solve for the total change in the internal energy. We can identify that delta U is equal to U2 minus U1, which is going to be equal to negative 735 joules. Then delta K is equal to K2 minus K1, which is going to be equal to 450 joules. So we can plug both these in and then solve for the internal energy. And if we do that, we get this. So this is the change in internal energy of the system for its motion. This means that the skateboard becomes hotter due to the force of friction, since the change in internal energy is positive. At the initial position, E1, it's all potential energy equal to this. And then at our final position, energy is all kinetic energy. E2 is equal to this. From his motion from E1 to E2, the friction force makes the guy lose this amount of energy, and it's converted into the change in internal energy of the system, which we just found. And we can note if we add all these, they sum up to 0, so energy is always conserved.